Hello chat, what's up? This is day 3 of building a computer in Minecraft. Let's go. So last time, alright, so as you can see, I've been working pretty hard off camera. Let me show you what I've built. This is a 4-bit ALU, minus 2 things that I'm gonna build today. And this is a working 16-bit ALU. In fact, I teased this in a short and a reel as well. Check out all my socials. Link in the description if you're watching this not live. Yo, Corey in the chat. Let's go the goat. Nice. So here you can see this is performing a really big and the subtraction right now. It's subtracting two big numbers right now, and the answer is absolutely correct. You can check if you want. And let me show you this other cool thing. Because the lamps are not visible in the daytime, I can just switch to night time. How cool is that? But obviously daytime is superior. So here's what we are gonna be. Hold on. Don't look at my iPad password. That would be hilarious. Anyways. So now here's the to-do list for today. Let's just my pencil doesn't work. Anyways, here's the to-do list for today. To do. First I'm gonna implement the flags. Flags in ALU. Speaking of ALU, while I have a working 16-bit ALU complete, I think I'll just stick with the 4 bits. Because, you know, with the 16-bit, the signal strength starts running out. You can see these glass towers carrying the redstone signal upwards. It needs to have these repeaters in the middle. There's so many signal repeaters in here. And yeah, that just increases the complexity. You're gonna log into my iPad. What? Hold on, the chat is getting cut on my third monitor. Anyways, so this is the working 4-bit ALU. Would you like to see it? I'll just show it to you. So here are the functions that it can perform. So this is the first input, obviously. This is input X. This is input Y. And then these are the controls that you can do. These are like the operations. So this is 0x. What this does is that no matter what input you give to X, it's gonna just set it to 0. So now this is all 0. I'm gonna turn this off for now. This is negate. So whatever you give it, it's gonna turn it into the opposite. So negating this would be the same as doing this. This is what negating does, and that's really helpful if you want to do negative numbers. Negating is part of 2's complement. In fact, 1's complement is literally just the negation of a number. And then we have the same for the y input, 0 and negation. And then this is the fun bit. If this is set to 0, then it will default to ANDing these two. So the output will be this and that. And you can see that 1 and 1 is 1, 0 or 0, and 0 is also 0. That also means that 1 and 0 is 0. That's the thing with this. Now if I flick this to 1, it's gonna add these two. So this is 0, 0, 1, 1 plus 0, 0, 1, 1. That's obviously 0, 1, 1, 0. Let's do a more simple addition. 1 plus 3, let's do that. That's 4, as you can see. Let's try, what should I try? 4 plus 1. Oh, this is really simple, 5. Yeah, but you can see this works. And then what this does is that it negates the output. So you can see 0, 1, 0, 1. It just negates that. 1, 0, 1, 0. Top to bottom. I should be reading bottom to top, but it doesn't matter. Now the way this does subtraction is absolutely crazy. Look at this. If I have 5 right here, and then I have 4 over here, What I'm gonna do is negate this, add them, and then negate the answer as well. So that gives us 1. 5 minus 4 is indeed 1. Now, you know what, just for the fun, let's try. Should we try 4 minus 1? Let's do that. I mean 4 minus 5 so that we get answer minus 1. Yes, this is minus. Hold on, this is minus 1, right? Let me just. I should be able to do this in my head, but let me do it written for sure. This is 1. Negate the bits and add 1. Yeah, this is minus 1. So a machine is telling the truth. Now the two things that I actually have to do are the flags in the ALU, as I said. So the first flag is what it does is that it tells us if the answer is 0. Hold on. Why can't I not write in cursive? Hold on. How do you draw a normal Z? Z 0 flag. And then the other flag, all it does is that it tells us if the answer is in negative. Negative flag. Okay, so you know what? I'll just clone this ALU to another place. I'll take everything from here to here. Thank you. And I'm gonna paste it. Where should I paste it? Right there, maybe somewhere. Alright. Let's just place it roughly here. What? Oh, right. This is where I want it to be. Okay. This is not where I want it to be, but it's gonna work. It's fine. It's not in a perfect line with these, but whatever. This is how it is. So, to make sure that the output. So, let's start with the first flag, the 0 flag. How do we know if the answer is 0? Here's what I'm thinking. I'll just OR all of these outputs. So, an OR gate through all of them because that's definitely the easiest to implement. And then I'm just gonna not it. So, if none of these are 1, then a flag will give us 1. That's how it works. Okay, so I can just destroy this output. We don't need these lamps anymore. Let's place. Oh, hold on. I'll need a repeater here as well because this is a signal strength of 1, I believe. Yeah, I think so. Is there. Can I just place torches? Will that be enough? Yeah, no, I'll need repeaters. That's how I'm gonna have to do it. I didn't need this block to be fair. Just gonna replace this with dust. Hold on, I can't see my hotbar. My third monitor is in front of my second monitor. However, this setup is. So I'm just gonna place repeaters here and then I'm gonna place a glass column in front of it. Just like so. Hopefully this meets. Oh, perfect. Okay, so a flag is gonna be at the top most probably because redstone glass doesn't like to travel up. I guess that's a flag right here. So if all of this becomes 0, let's just should all be 0 now. Wait. Hold on. Some things. Oh wait, I know what's not right. Hold on. What's in these inputs? What was I doing? Let me just turn all of this off. Perfect, now it's in a reset position. And look, the flag is on, the torch is on. That means that the answer is 0. That's all this flag is gonna tell us. And then... okay, so this task is done. Let's just strike it off with green. Now for the negative flag. So actually let's have a look at how negative numbers work in this. Alright, actually you know what, why don't I just use the machine that I already have. Let's do 4 minus 5, our old example. Let's do it again. 4 minus 5. And then I'm gonna negate this, add them, negate the answer. What's it giving? 1, 1, 1, 1. Right, that's what we just discussed. Okay. So as you can see, the most significant bit actually acts like the sign bit, because whenever you have a negative number, the most significant bit will always be on. So why don't I just use that as the flag as well? Seems simple enough, right? A small packaging issue. Where do I place? Oh, simple. I can just place a repeater here. Perfect. I might as well color code this. Is that it? Is that how simple it's gonna be? These are the two flags. That tells us it's a negative number. That tells us the answer is 0. Perfect. Or rather, it tells us the answer is not 0 at the moment. Let's test out the flag. The one for the negative number. As you can see, it was working. Let's see if I'm getting a positive number. 4 minus 1. First of all, the answer is 3. The flags are working correctly. Let's go. Now the other things rather that I wanted to do today. Let me write them down. Hold on. The iPad's gonna take a bit of getting used to. Now the next thing, the ALU is complete. As you can see, this is a working 4-bit ALU. It doesn't have multiplication or division, but those things can be emulated in software. It's not gonna be a big problem. If I'm just gonna run simple games on it, I wouldn't even need division. But yeah, anyways, the other things that I wanted to do today, just play around with the memory a little bit. Try memory. The RAM of the computer, essentially. I might as well strike this off. And I can strike this off as well. Very cool. And by the way guys, you all should subscribe to the channel. This series is hopefully about to blow up. So here's what I was messing around with. So yeah, let me just show you. Oh, look at that. I'm pretty proud of this little thing. Some of you might be able to recognize what this is. This is an RS NOR latch. Let me show you the thing where... let me just build a new one actually. So let me show you what I'm using for the AND, the OR gate. So first of all, this is some relatively lesser known tech. So this is glass, a transparent block in terms of redstone. And the weird thing about this is that the signal can go up but not down it. Whereas if you just replace this with another block, then the signal can obviously go right over it, but not with glass. It's a transparent block and apparently Mojang doesn't allow it. So yeah, this is what I'm using. So this is better than using repeaters on both ends because this reduces the delay a little bit and makes it a little bit tiny bit more compact. So let me just build an RS NOR latch right now. Very simple tech, by the way. I think everyone knows what an RS NOR latch is. For those of you who don't know, I'll obviously explain it as well. So this is a first NOR gate, and essentially if any of these inputs is on, then the output, which is this torch, will be off. Now the second gate that I'm gonna construct is gonna use this torch as one of the inputs. That's the really cool thing about this. Now obviously this is, how do I say it? This can get you stuck in a bit of a loop, but that's exactly what we want here. That's the purpose of this redstone technology, or rather real life technology. Hold on, so it's gonna be like this. Perfect. Now I just have to redirect this input from, let's say right here. Alright, this is the RS NOR latch. And here's the really cool thing about this. If I just place two levers right here and I use one of these as the output, then you're gonna see some really cool stuff. So if I turn this on, the lamp is already on. Hold on, what's this green box in the bottom left? How do I make my iPad not sleep? Anyways, so if I turn this on, the lamp turns off, and then I can turn this on, turn this off. Doesn't really matter because this circuit remembers its state, and that's what's really cool about this. If I turn this on, the lamp obviously turns on, but it remembers its state. So look, this is basically a toggleable thing. Now the circuits that we've built previously, such as the ALU over there, all of this in fact, all of these are combinational circuits. So the output only depends on the input that you give them. Whereas this one, it remembers its state, so the output also depends on its current state. Like this. You can spam one of the inputs, it's gonna do nothing because this circuit remembers what it's supposed to do. Look how cool is that. So yeah, this is what we'll be using for the memory because obviously this can remember, so we might as well use it for memory. And this is where this contraption comes in. And you know what? I've made so many iterations of it. I'll just show you. Hold on, does this work? That's the question. But it does the exact same thing. So let me just label the inputs as well for your clarity. This is which one? Yeah, this is the main input. This is input in. This is the load input, and this is the clock. Yes, this is clock. Your RAM has a clock speed, right? For me it is 5200 mega transfer per second, which I have clocked down for stability. But yeah, so this clock will be turning on and off. And the thing with these things, the thing with the RAM is that it will only function when the clock is on. Oh, I just burnt a torch. I just burnt this torch. Wow. But anyways, and then we only want to write something to this chip when the load is on. So when we are telling it to load something into itself, then we are gonna turn this input on. This is obviously our input. So let me show you how it works. The clock is on, the load is on, and then we input something. So that lamp turned on. Now if we don't want to load something, we just turn it off. And now the lamp remembers its state. Look, I can turn this off. I can turn this off. And yeah, look, that lamp is still on. In fact, I can turn on or off any of these inputs and that would do nothing to the lamp because it remembers its state. But now if I want to write a 0 to it, I can turn on load and clock and this should be 0. And look, I have written 0 to that lamp. This is how it works. And then here I have the same thing but a tiny bit faster and a tiny bit more compact. Yeah, I'm all in for efficiency this time. And then I have the same thing stacked. So hopefully this is gonna act like a working RAM in Minecraft. I'm building RAM in Minecraft because and then I'm gonna sell it to data centers. Yes. Genius idea. So this is so yeah, this is the clock input and this is the load input. So here's what I was doing. I was building a glass tower for it last time. Oh, hold on. Because this is 3 blocks tall, I can't use a glass tower for this. Oh, no, no, no. See, the thing is, the glass tower. Let me show it to you. This bit is 4 blocks tall. And this bit over here, is 2 blocks tall. Hold on, can you also see my Discord integration into Minecraft? That would be weird. So yeah, the glass towers will only stack if they're an even number of blocks, whereas this thing is 3 blocks tall. I got to figure out something. Will it still work? Yeah, I think I can get it to work. Hold on, no, no. I I don't think. Uh, let's just try. I might as well just try. I don't know if it's gonna work or not, but we'll see. We're not gonna need these anymore. We already have the clock and load at the bottom. Oh, by the way, if I sometimes call this clock and this load, then it literally does not matter. This is an AND gate over here, rather a NAND gate. So it's gonna be the same thing. So now let's clone this. Where do I clone it? Here. Oh, I did not break it. Let's go. Can I break this portion? I don't think I'll be needing this stuff. Okay, hopefully this is a working glass tower. What's with all this redstone? There's so much redstone dust in here. Well, okay, so this signal is not supposed to get onto the glass tower, is that right? Oh, but it still can get onto the glass tower, that's the problem. Oh, hold on, it cannot, because it can't travel down the glass. That's actually perfect. So the signal can go from here to here to here. And it can go from here to here to here. But it can't go the other way around. Or can it? Oh no, it can. So this torch can actually power this glass tower. That would be suboptimal. So if I turn this off, yeah, this is not good. So because of this input, oh, now the upper half of the tower won't work. How do I fix that? So this torch is powering this stuff. Why don't I just block the signal out? No, hold on. That's not how I wanted it to work. Okay, but it is progress. So this torch is... You know what? I think I might be cooking. If I just replace this with a target block... Oh, did that solve the problem? Only one way to find out? How is this gonna be powered? Oh, what am I gonna do about this one then? Rather, this one actually. That target block did nothing. Oh, why don't I just move the glass tower a little behind? That should have been the obvious answer that I should have done ages ago. Hold on, I lost track. How was this built? Okay. Not too difficult. Glass here. I really hope I don't break something here. That would be kind of sad. Okay. So the signal has to come up from here. You know what? I might as well just start over. Why don't I just disconnect my iPad because I'm not using it at the moment? Now hopefully the green thingy should go away at the bottom left of my screen. Okay. Where do I clone it? Right here? There you go. Alright. So, where should the tower go? Let's see. Let's clone this one more time. Can I place it here? You know what? Maybe I should. Yeah, this is where I was trying to build the tower. Yeah, perfect. What can I do about this? What? Why is it getting powered? Oh. Yeah, I don't want this thing powering the glass tower. What if I just separate the input? Right? That sounds a bit obvious. I'm a little lazy, so I might as well just clone these things. That's an easy reset. Okay, so I need this input and I need it to go up a glass tower. Maybe like so. Hold on. So signals from here can't go down this glass, and the signals from here cannot go down this glass either. I might be cooking. Hopefully. And we're not gonna be needing these inputs anymore. So now hopefully it's gonna be... Yes, this can store 4 bits now. Oh perfect, is this it? Let's try. I turn this off, the entire thing should. Oh, perfect. So now I shouldn't be able to write anything to these lamps. Oh, perfect. If let's say I want to load something but it isn't the correct time, as in the clock is off, nothing, I'm not able to write anything. Now if I turn the clock on as well, oh, I just wrote it, perfect. Now I can write anything to these, and then if I stop loading, then it's gonna remember what I wrote to it. No matter what these inputs are, it's gonna remember. Perfect, we have a 4-bit memory ready. Perfect, we have a 4-bit register. Time to turn this into RAM, and then I can sell it to Nvidia, right? Is Nvidia a good guy or should I sell it to Microsoft? You guys tell me. Did I forget to input the coordinates in the clone command? Alright. Let's just build it right here. Okay, so this is a 4-bit register. Now, what do we want it to do? I'm gonna connect my iPad once again. External display, is it actually mirroring the display or is it just gaslighting me into thinking, oh yeah, it is mirroring the display? Where did it go? Anyways, dry memory, that's what I'm doing right now. So, what's RAM supposed to do? Let's just talk about it right now. So, let me draw RAM. Let's draw it as a black box abstraction. We are going to be able to give it an address A, and then the input, let's say in, and then we should be able to tell it if it has to load that in. And then obviously it has the clock input as well, but half the time we can just ignore that. We know that these things are clocked usually. Yes, I will fix the RAM shortage. I'll make RAM that requires RAM to work. I'm such a genius. What, 10% battery? Okay. Never mind, it's fine. 10% lasts a long way on these devices. Hopefully. So we have the clock input, we have the load input. We obviously have the in input as well. That's literally what I've been building. But what about the address? What is that? So basically, if I just clone this a few times, then we'll have a few bytes, or rather, in this case, a 4-bit byte is called a nibble. So we are gonna have multiple nibbles in our RAM. So now what I'm thinking right now is, should I stack this vertically or horizontally? Because multiplexers are typically vertical, right? Everything that I've built so far has been vertical, other than this thing which I've obviously stacked vertically. You know what, should I build a multiplexer first, because I'm gonna need that for this, for the RAM. And I might as well start working. You know what? Let's enjoy. Let's clone this and then we'll see. I'm gonna clone this right here. So now the address is gonna let me decide which of these two registers I have to write data into. So here's what I'm thinking. I'll have the main input, and what that's gonna do is that it's gonna try to write the data to every single one of these registers, but then the load signal will only be given to the correct register. So for that I'll require a demultiplexer. Oh, this should be simple. So I just have to give the load signal to the correct one. Let's just duplicate this register. How many times should I? Let's ask chat. So chat, if I want to have RAM, I want to make this section of the RAM. I might duplicate it again, but how many registers should I have in one section of my RAM? You guys suggest something reasonable, please, and I'll do that. Genuinely. Let's see what chat has to say. So we have 5 concurrent viewers. How many of them are subscribed? Let me check real quick. 5 concurrent viewers, that's insane. Oh, I gained 0 subscribers so far. Guys, let's all subscribe. I'm just gonna build. So if the chat doesn't suggest me anything, I'll just build uh, 8 registers in that bit of the memory. Let's just play some music as well. What should I play? Yes. Alright, so I'll just build 8 of these. Hopefully that's not too much. 8 seems reasonable to me. Once more. Alright, that's 8 if my counting is correct. Now let me just start with building the demultiplexer for the load. So since this is 8, we are gonna need 3 inputs for the address. Oh Corey, I think you got a tiny bit late. Hold on, is there some stream delay? No, the chat is delayed. Yeah, I think there's around 15 seconds of stream delay. That's unavoidable, sadly. Okay, so we're gonna need we're gonna need 3 bits for our input. I accidentally held my trident and it started raining. Don't mind that, please. Let's just make our 3 inputs here. And I'll extend them a little. You know what, I might as well build the logic portion here. Let me draw out the inputs. So here we have 1, 2, 4. That's how binary works. This. Now for this one, when all 3 of them are 0, then this load signal should see what we give it. So that means that I have to build an AND gate first of all. That's a first order of business. Okay, so there was a torch on the other side, which means that I can just soft power this block. Alright, and then De Morgan's law states that we need redstone dust here, and then for the inputs we need torches. Maybe right here. I can't see my hotbar, this is disorientating. So one of these will be the address signal. So if all three of these are off, then the address signal will be on. Let's draw this over here using yellow because so now I'm gonna AND all of these together using a massive AND gate. Hold on. So if 1, 2 and 4 are 3 bits of the address input, if all of them are gonna be off, then all 3 inputs of this AND gate will be on. So that means it will give 1 as the output, and we'll feed that into one of these inputs of this AND gate, and the other will be a load input that the user will give into this RAM. If both of these are 1, then we'll get an answer here. Of course, I'm gonna optimize this as well. We can't have a NOT gate in front of a NOT gate. That's not something that I do. Let's break this down into Minecraft language. NOT gate here. Okay, I'm gonna simplify all this when I build it in Minecraft, obviously. All of this will go into a big OR gate, and then the answer will be NOTed. And then let's build this part over here. I'll use, you know what, let's turn this into white, and then let's use yellow for all of this. So you can see a NOT gate here, which goes into OR with the NOT of another input. And this is gonna be our load input. Okay, so this, and then after that we have a NOT gate. After that we have yet another NOT gate. Alright, let's see what I can do about it. First of all, let's start with the obvious stuff. Hold on, no, this is not supposed to go onto that tower. Let's think about it. If I place a glass here... Oh, I need to place it here. What am I doing? Yeah, perfect. So this is essentially a diode in Minecraft. Look, the signal can't go from... Oh, this is the opposite of what I wanted. What am I doing? Okay, that works. So now the signal can't go from there into this gate. Although that won't make a difference, would it? Let's just keep it simple. Now for the inputs of these two gates, Okay, so let's draw out what I've built so far. Here's what I have. This is feeding into the machine. This thing, this is this wire. Here we have the OR gate, which is taking input from these two NOT gates. One of these will go to the load. The other is actually coming from a NOT gate itself. I'm gonna build this portion here. Okay, I really need to charge my iPad. I'll just plug a wire into the back of my PC. I have a strange feeling I messed something up. It's fine. The stream is still running, that's all that matters. Okay. So now we have to build this bit. Three inputs. You know, I can just feed these three inputs into a NOR gate and then just remove these two NOT gates. Is that how simple it really is? One way to find out, we'll see if it works. So because of how simple an OR gate is, I might as well just build it right now. Like so. These will be our three inputs. Might as well color, grade color correct. What's it called? I might as well color code them. So if my plan is correct, then the signal shouldn't be able to go down from here. Simple diodes in Minecraft. Okay, so if all of these are 1, then it will turn this torch off. And it will turn this bit off. I think that's exactly what I want. And then this load over here is gonna be pretty simple. Where's the lever? There you go. Let's see if it works. I'm just gonna do very manual testing right now. So when all three of these will be 0, then our load signal should be able to go through, but it's not going through. Why is that the case? Oh. Something's definitely broken in my logic. Hold on. Let's draw out what I've built. So I've built our inputs. Let's look at it this way. Our inputs 4 to 1. They are going into just an OR gate. That leads into a NOT gate. Into yet another OR gate. Here we have a load input also getting knotted into the same OR gate. And then this goes into the load of the machine. So Oh, what's this not gate doing? Oh, I found out the problem. I think this is exactly what's not right. If I just replace this with the torch, hopefully it should work now. Okay. The signal strength doesn't seem to be running out. It should work. Our load signal is going through. If I just turn one of these on though. Oh, it's still going through? No, no, no. Oh, because the signal strength is running out. Yeah, that makes sense. That checks out. How do I do that? Simple repeater. How's the signal strength looking up here? Quite fine, I guess. Okay, so repeater was unavoidable here. Oh, seems like this is working. If any of these inputs is on, then this would not receive the load signal. Alright, you know what? Let's just actually build this. There's surely there is a better way for me to build this. Where's the torch? Okay. And just bring this one block closer. Can I just have all three inputs feeding into this one glass block? Would that be ridiculous? A little bit maybe. I might as well make the other inputs right now, because if one of the input is being problematic, then we really do have a problem. The target blocks are such a game changer. Has anyone ever thought about the target blocks? Okay. This is our input. Yes. Perfect. Oh, where do I feed the third input into this? Actually, you know what? It doesn't even matter. I hope the signal strength will run out, and then let's just have one input for this. You know what? Why don't I give the other registers the same treatment? I can just clone this portion from here. Over here. What? What? No, no, hold on. Where have I cloned this? Something's not right. Okay. Well, that was awkward. That could have gone a lot worse. Okay, from here to here, I believe. To here, actually. This is quite a bit more compact than the markers are indicating. And I'm gonna clone this here. Okay, great. And then here. And lastly over here. Okay. Now as for 3 inputs. How do I feed the 3 inputs? Oh yeah, I should make a backup of everything. Should I make it right now? I'll make it after this stream for sure. Okay, how do I make the inputs? Do I just have a bus running underneath everything? Oh, above it would be more practical since I have a lot of free space over here. So I'll just make the buses running overhead. Seems fun. Oh, I overshot. How much? This? Okay. Actually, let me check if... Will this work? No. And then I gotta build this over here. And then over here. And then here. What? How is there no green box in the bottom left? That's weird. Anyways. I'm just gonna break this bus. Okay. The inputs, where do I make them? Logically, I should make them right in the center. Let's count how many redstone dust I'm using. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's place a repeater right here. My mouse almost fell off my table doing that. I might as well just fill the entire thing using redstone at once. Easy. Now if I have the inputs going right down the middle, this is gonna be the first input. Oh, hold on. Let's just say this is 4, this is 2, this is 1. So 1 is gonna have to cross over the entire thing just like so. 2 is gonna have to cross over this bit, and 4 can just connect directly. Just like so, these are the inputs. Where's the lever? Let's see how far the redstone signal reaches. Hopefully far enough. Alright. Over here. Not much actually. But we can still move the inputs by 3-ish blocks. So I move this over 1, 2, 3. How much do I have to move them? 1, 2, 3. Oh, 3. And I can move them by how much? 1, 2, 3. Hold on. So I might as well remove these 1, 2, 3. Oh, I can move this 4 blocks. Okay. I might as well do that. 1, 2, 3, 4. Okay, I'm moving my entire set of inputs because the signal strength is running out instead of just using more repeaters like a sane person would. Now I can destroy these inputs. Oh. Oh no, the goat has to go to bed. Alright, good night. Oh, okay. I just went from 2 concurrent viewers to 4 in an instant. Let's go, welcome guys. I'm making a computer in Minecraft. This is gonna be a fun series. Let's see how many did any of you guys subscribe. I'm still at 97. What? Well, this series is about to blow up. Just saying, so you better subscribe. Okay, hopefully the signal strength is... Oh, perfect. This is being powered, so now I can hopefully do something. Hold on, but the question still remains. I need to get these inputs into that thing over here. Okay, we have signal strength here. The question is, oh, it's not gonna reach there, is it? Chat, we might need more repeaters. No, no, no. Okay, okay. You know what? It's not that bad, right? Will the signal reach here? Oh no, it won't. Oh, I can just bus it. Oh, why did I not think of busing earlier? I have no idea why it's called a bus. But if it works, it works. 2 extra blocks of signal strength. I'm gonna take it. I Can't see my hotbar. My phone is in the way. Let's go. Signal strength for free. You know what? I'm gonna move my set of inputs yet another time. 1, 2, 3, 4. Let's move it by 4 again. Like this. This goes over these things. And then for this one, it goes over this input only. Okay. Now I think I can just bust these as well. Should it go here? Oh, miscalculation. Hold on. This will not be able to... Okay, it's a miscalculation by 1 block. I'll be able to deal with that. It's fine. Not that bad. 1 block off from what I was expecting. Just like so. Oh, is that what? That should be working. I think it will work. So when all of these are 1, that turns into 0. Oh look, I think the input is gonna go through. Let's just try. All of these are 1, so it's giving a 0. Perfect. Yeah, so I can now load this. Oh wow, that's amazing. I can load this and write whatever I want. Yep. That lamp turns on, that lamp turns off. Oh, perfect. Okay, wait. I just realized, where will I route these inputs? Do I just... is there enough space for me? So I'll have to cross from these wires. Oh, perfect. That's actually great. I have enough space to run these inputs. I was slightly concerned. Alright. Let me play some music real quick. Let's not play the same thing again. Ooh, yeah, like funk. I have Sahara Walmart version. Isn't there supposed to be a torch here? Yeah, where did the torch go? The torch just vanished into the back rooms. Anyways. We don't need this anymore. For the second one. Why is there a bus in the way? No. Alright, let's do some calculations. So for input number 1, 1, 2, 4. Now I think I should just not the first input and it should work just fine. this is our very nicely designed OR gate. Okay. Yeah, I figured it out. I'm gonna place a torch on one. Just like yeah. It's gonna be a little bit crooked, but it's fine. There's a bus in the way. What else am I supposed to do? Like this. Okay. This is working so far. So far, so good. And then we need a repeater over here. How am I gonna do that? Can I just use this repeater? Can I just make this line plummet a little? Okay, like so. Hopefully this torch isn't powering this line. Oh, it will be able to. Yeah. Guess I'm just gonna use the repeater then. Where do I place it? That's the question. Here? Oh, I know. I can make the rest of this line powered from this bit of redstone. Oh, I know, I can just use this bus. Oh, that's great. So now this torch can power this bus and so can this repeater. Now as for this one, we need a repeater here as well. Luckily, if I remember correctly, this bit is really simple. You just put a repeater here. There was a way to get rid of the delay too. Was it? Or was it the other way around? Oh no, it was like this. Okay, so now the signal not only goes right over the repeater but also into the repeater and into this line down here. That's perfect. 3 down, 5 more to go. You know what, let me just test it real quick. So I'm gonna... Let's just turn on all the load signals right now. Hold on, why do I have this torch here? Am I literally not just giving it the load signal? Oh no. Okay, I might as well just make... I'm gonna make the load signal right now. So the load signal is gonna feed into each of these thingies. I can't even drag click anymore. Okay. Let's see how much the signal strength is. Redstone wire, it's called for some reason. Oh no no, it's not supposed to be powered like that. Oh, luckily the fix is simple. There you go. Hmm. Oh no no no. Packaging is a real problem here. Well, how do I? Can I make this bus move away? Oh, hold on, I still haven't finished this portion here. Oh, I can just connect these because we have repeaters here anyways. Is this signal able to reach all the way into the repeater? Yes, that's good. So this seems to be working pretty well. Oh, let's see, is this signal able to reach here? Oh yes, it is powering the repeater. That's perfect. Can I perchance move this bus a little backwards? That's what I'm thinking right now. Can I? How much signal strength do I have in here? Okay, one more. But no, I don't think that would be worth moving the entire bus a little backwards. Hmm. Okay. Is there any way for me to move this input somehow? Oh, I can just make this input drop from here. The line can go down from here. That's actually pretty good. Perfect. Now I can get rid of all of this. Let's see if... Oh, perfect. It is sufficiently powered. Now I just have to connect this bit over here. Oh, hold on. There's a torch in the way now. I think if I just place this torch here, now it's out of the way. Let's go. Now I can just place redstone dust all across this thing. 3 done, 5 more to go. Okay, so these are the load inputs. I'm connecting the load input to each of these, but this is kind of an AND gate, so it will only give the load input to the register if the address signals are correct. So that's what I'm trying to do. Okay, perfect. Might as well color code this bit over here. What? No, no, these are not supposed to meet. Easy fix. Okay. Oh, I should increase my streaming bitrate. My phone keeps buffering. That could just be my data plan though. Okay. So here we have all the load inputs. I'm just gonna make, I'm just gonna put a lever in the dead center. Let's see how far the signal strength reaches. Or doesn't even reach that far. I'm gonna need repeaters everywhere. Place one here. Oh wait, I might not need one here. Oh, but it doesn't even matter since I'm gonna be placing more repeaters. Okay, that works. Oh, hold on. So there's gonna be a maximum of 1 tick delay. Okay. No, a little more than that. You know what? I can actually just move the thingy. I can just move the torch a little bit. There you go. So for the one viewer that tuned in right now, I'm building a 4-bit piece of RAM. So each of these vertical columns that you see, this sort of tower thingy made in orange and blue, this is a 4-bit register, and I'm making 8 of them. And here you can see this these 3 inputs. This is the address. We can use this to select which register we want to write or read from. Hold on, I just had a thought. I'm also gonna have to make something on the other end. I'm gonna have to make a multiplexer here, and it's gonna have to take these 3 same inputs. So where will I run those inputs from? From here? From one end of this to the other end? Or should I just run it right down the middle? That would be the more logical idea, but I'll have to shift everything then. I don't know. Maybe I'll just run the inputs from the bottom. Well, we'll cross the bridge when we come to it. Right now, I'm just glad that this is done. The load thingies are done. Okay, so if I'm giving 111, then this tower has turned off. So that means that I can give this some input. And the lamp will, and this will remember it. Yep. If I set this to 000, then we can write something to our first lamp. Can we? Why is this on? Oh no, this wire is receiving a redstone signal. It's supposed to giving it's supposed to be giving the signal down. I'm not receiving anything from this torch. How do I make this receive nothing from below? Well, that is a bit of a challenge. If I replace this with a glass block, then it's not gonna be... Oh, I know. I can just place a block here. Okay, so now this glass tower has turned off, which will allow us to write stuff to this register. Let's try writing something. Oh, let's go. Hold on, my concurrent viewers increased by 3. Isn't that a little suspicious, right, chat? I see what's going on. Anyways, so as you can see, we have this one register over here and I'm able to write to it now. I turn this torch off, the lamp goes off. So I have inputted 0 into the address. Let's try inputting 1 into the address. The glass tower goes on, which means I can't input anything here. Perfect. Cut it off. Okay. And then we have a second one over here. So now this glass tower should have gone off, but it hasn't. What's powering it? Oh, my bad. I think I confused the fourth input line with the first one. I might as well change it right now. This is line number 1. Oh, but this is supposed to be line number 1. I'm gonna have to fix something. So this torch is supposed to be on this line. Okay, that was easy to implement. But now that has probably broken things. No, it hasn't. Okay. Very cool. I'm just gonna have to take an input from this repeater. I can just place another repeater. Where do I place it though? That's the question. Like this, maybe? This works, I guess. But then, how do I take the signal from here and give it over there? Like this, simple. How is it receiving power? What's powering the entire thing? Oh, this repeater should not get to power this line. Oh, that's a simple fix, a glass block here. Oh, I did the exact opposite of what I wanted to do. Let's see. So we have repeater here. We don't have repeater here. Hold on. No. This is not how it's done. Where's the repeater for this one? I can place it here, maybe. No. Oh, where do I place it? Packaging constraints. Oh, right here should work. Wait, what if I place it backwards? That should work too, right? Oh wow. Has anyone ever seen a repeater go backwards? It's literally facing. So signal comes from there through this repeater in that direction, but this repeater is facing the opposite direction. That just breaks the rules of redstone, but whatever. FixoGenie is the most unhinged tech channel after all. We have repeater here, and a torch here. Why is this still on then? How is this receiving power? What? Oh, no, no, no. So, repeater here is not gonna work. I learned that the hard way. I'm just gonna have to move the entire green line a little backwards. Uh, Anything in the way? Nope. I can clone this here. Right. Oh, wrong block. From here to here. Like so. Oh, perfect. Okay. Then I'll just break all of this. Oh, my scroll wheel is getting old. Hopefully, this doesn't make the signal strength run out. That's very likely though. Alright. Let's place a lever here. Oh, let's look at the chat. KD the Cuber, let's go the goat. Yo KD. KD the Cuber is the goat chat. Shout out. Anyways, what? Can you marry me? What was that? So scary. Hold on, how delayed is the stream? Oh yeah, Enderpearl, let's go. Ball knowledge. Elite ball knowledge, let's go. Let's see, is the signal strength... where is the signal strength running out? Right here at the very last block. Luckily, that's an easy fix. Hopefully... Okay, cool. I think that does work. Yo, I'm so charismatic. Let's go. Can my computer run on diesel? Well, there's actually... Oh, I think my friend Grace has a theory that redstone is actually uranium. How cool is that? And uranium can also be red. Look, it's emitting red energy. That means it's uranium. So yeah, this runs on nuclear energy. A small fun fact break. Now I just got to make sure that all these torches are receiving power. Yes, they are. Perfect. Yes, let's go. Hold on, what's this torch doing? What is this torch powering? What? Nothing? I can just break this? Or is it just increasing complexity? Oh, it was supposed to be powering something, but it wasn't powering it. Well, that's weird then. Guess I'll fix it. Okay, this should work hopefully. I haven't tested any of this. I should test it. I should build this first and then I should test it. I'm a little bit concerned that it won't work. Uh, this is a pretty simple thing. It's a decoder. I believe this entire address thing is based on a decoder. Can I get a high? No, I cannot do that. So I need this is gonna be the input number 2. One was before that. Let me just draw it out right now. Is the screen working? Yes, it is. I should get a narrator to read the chat. That would be so interesting. Katie wants to ruin a grandship. Anyways. So oh, rough overview of how this is supposed to work. Really interesting question. Okay, so actually let me show you the ALU right now, the most interesting thing. I'll just pull to it. There's the ALU. The 4-bit ALU. I'm continuing with the 4-bit ALU. The 16-bit ALU works perfectly well, but you see these glass towers, they actually need repeaters. So that delays the entire thing by quite a bit. And then having 16-bit memory and all that will be kind of a bottleneck, I think. But yeah, this is the ALU. Let me show you all the functions, all the bells and whistles that it has. Now the really interesting thing about this is that it's built on a full adder and a 4-bit adder, that's what it's called, and that is the blue thing. And this can do addition as well as subtraction. It can't do multiplication, but I'll just be able to emulate that through software. So the software running on top of the computer will have the capability to perform multiplication, but it will literally just be repeated addition. It can't do division, but it also doesn't need division. So yeah, let me just show you. Let's do 3 plus 2. It should be 5. So currently at the moment, it's gonna do this is gonna do this input, X input, and Y input. So that's why you can see that only this repeater is on. It's doing AND of these two. But if I flick this lever, then it's gonna add them. So it's gonna do 2 plus 3. It's gonna give 5. So the bottom repeater is on and the one at 4 position is on. But the way it does subtraction is really interesting. So we have this input which negates the x input, and then we have this input which negates whatever output it gives. So now you can see that it's giving -1, right? This is 4, this is 5. So yeah, it is giving -1, which is 1111 in binary. And look, that flag is on. And what that flag is saying is that this is a negative number. Can it do 1 plus 1? Of course it can. Let me just give it 1. Let me tell it to do addition. Let's see if it can do 1 plus 1. Oh yes, it can, look. That's the 1 bit, it's off. This is the 2 bit, it's on. This is the 4 bit, it's off. And the 8 bit is also off. So the answer is 2. So this will be the brain of the computer. And then what I'm messing with over there is the memory, the RAM basically. And now, oh yes, this RAM thing, let me just show you the diagram that I made. Let me just turn on my very smart whiteboard over here. So this is the high level diagram of the RAM. It's also gonna have an output. Actually, let me mark this 4 bit. And then this is gonna be 3 bit. Load will be 1 bit, so it's a boolean value. And then this will have an out of 4 bit. Is the whiteboard visible? Oh yes, it is. Let's go. So the in input is basically the data that you want to write. So the 4 bits of data that you want to write, this is a register and it has 4 inputs. This is the first one, this is second, this is third, and this is fourth. And this is the so the first input of our RAM is obviously the data that we want to write. And then we have the load. So what this does is that it tells the RAM that we are writing something. And then we have the address. This is telling the RAM where we want to write it. And if we don't want to write something, then we'll just set this load as 0. And then we can just read that segment. So this RAM has 8 of these registers. And then if we want to read, let's say the register at the second index. So we give it 010 in the address section, which would be 010. So now it's connected to this one. Hold on, let me actually show 011 as an example, because I have that 001 as an example because I have that working right now. So this is the load. If I turn it off, then I'll be able to read it. It's work in progress right now. But if I turn it on, then I'll be able to write to this RAM chip, to this register. If I just place a lever here real quick, like this, you can see this lamp turns on. If I turn it off, this lamp turns off. And then if I turn off load, then you can see that this thing still remembers its value. This is off right now. Even if I turn it on, it's gonna remember that it was off. So this is the register. It's gonna remember not only the values that the program is working on, but also the instructions. I'll talk on that later. I'll cross the bridge when I come to it. And then we'll also have the program counter, and it will be counting which instruction it has to execute. So yeah, that's a pretty lengthy rough overview of how the computer is gonna work. I hope that answered your question. So anyways, let's continue with building this thing, I guess. So this is our input for 1. Yes, phenomenal indeed. I'm gonna mark this 1 so that I don't mess this up again. 1, 2, 4. Okay. So now let's do the third register. There's a bus literally in the way. How am I supposed to place anything here? Let's go. Crystal clear qualitative answer. Thank you. Let's go. So for this one, oh, this is 0, 1, 0. So that means torch goes here, and we should have repeaters here. I'm gonna place the repeater over here. Perfect. And then, oh, there's a bus in the way. How am I supposed to make a good connection? Oh wait, I can just put the repeater on the glass block. Wow, that's easy. Let's go, you understood this a little bit. I have done the impossible. That's what FixoGenie is all about. This is the most unhinged tech channel on the planet. I took a keyboard and then I put glue inside it, and then it actually sounded good. Yeah, that's FixoGenie core. So anyways, let's see if this bit works. Oh, let's go, this glass tower turned off. Nice, I might be cooking. Now let's go on to the next one. Redstone dust over here. What am I doing? What's in my aim these days? So I've got to place torch over here, not gates, and then diode thingy over here, I think. Oh, okay. I'm gonna have to replace this with glass. Wait, this is is the signal just gonna... oh yeah, it's gonna connect to the glass. So I want to place a repeater. Let's see if I can place it over here. Can I? But the signal also has to go over it. Well, I should genuinely get a narrator to read the chat. It's gonna be entertaining. Oh, we have 7 concurrent viewers. Hello guys. I'm building a computer in Minecraft. I'm currently working on the RAM chip, as you can see on the whiteboard. And what I'm doing right now is that so these are the address bits. These 3 bits will tell us exactly which register we want to read or write the data from. And so I'm connecting these address wires to the registers. I'm mapping them correctly. And it seems to be taking a bit of time, but it's still quite fun. I'm enjoying it. Okay. The question is, how do I place a repeater here? I'm supposed to place a repeater here. You know what? I'm just gonna place it like so. I think I know what to do. Oh, this can work. I have an idea. There you go. So we have repeater here, torch and torch. So that's the input at index 3 complete, next to the one at 4. I just double clicked my spacebar because my stabilizer is a bit broken. Not my fault, chat. Okay. So I need a torch here. Easy. I need a repeater here. And here. Okay. Oh, will the signal be able to travel all the way to the repeater now? That is the question. You know what, I'll just move this behind a tiny bit. Like this. Okay. So we don't have... Oh, 100 subs. Let's go. Let's go. Thank you guys. I hit 100 subscribers on a live stream. That's insane. Thank you guys. Let's go. 100 subs. You know what? Let's do a quick celebration right now. Let's build a table out of the very block that I was using. Let's build a small table. Cake. Candle. Did I just eat the cake? Well, let's go. Let's go 100 subscriber special. Alright. Anyways. So now I was in the process of making this redstone signal reach the repeaters. Let's go, that's done. And now this glass tower turns off. But if I give it an input of 5, then it turns back on again. Perfect. That means I can move on to the next one. So I need a torch over here and over here. And a repeater over here. Shouldn't be that hard. Yes, party time, let's go. You know what, let's actually party about this. Today is 8th July. In 10 days, I'll actually throw a 100 subscribers party. Go-karting on me. Anyways, very niche joke. But let's see. So this glass tower has turned off. And oh, it turned back on again when I gave it 6. Perfect. Oh, this is the last one that we have to do. This is the last register that I have to connect. Torch here, torch here. And then repeater here. Okay, so the torch, the glass tower has gone off. If I give it 7, it turned back on again. And then, oh, this one turned off too, perfect. Let's try cycling through all the possible address inputs. So that last tower is off for 0. For 1, that turns back on and this turns off. Let's try 2. This turns off. 3. This turns off. And then let's try 4. Okay, it's working so far, so good. Okay, that one. And then for 5. No, this is 6. That one turns off. And then last one 7. Let's go, perfect. So now I can select which RAM to give the data to. But now let's see how I'm actually gonna give the data. Let's just start building the data lines. Wouldn't it be cool to have them all inline? I think so. Let me just okay, but the question is, hold on, how am I supposed to get the input from under there to here? Okay, there's nothing on the bottom of this. Can I just move this down a tiny bit? And then okay, this is a little difficult. What if I have glass over here? Okay, then this is gonna connect. Now this input is gonna enter this stream. That won't be good. Oh wait, I think this is working. Nice. Okay. Let me just play another song. Oh, I know exactly which song to play. Oh, wrong song. Anyways, doesn't matter. So I'm raising the bottom input by 1 block as well as the top input. Perfect. Why don't I just raise every input by 1 block just for the sake of consistency? What? Okay. Also, I've accidentally written zeros to this register because the address lines just happen to be at 0. Okay, so all the input lines will connect at the front, I guess. Oh. Hold on, how am I supposed to place the... Where am I supposed to put the address lines then if the input lines have to come here? Hold on, this is taking way too much space. Is there any way to compact all this down? Let me try something. Is there some way to make this go upwards? Oh, I haven't even implemented the clock yet. Oh, but luckily I think shouldn't be that hard. I can just have a line running under these things having the clock signal. Maybe I can input that directly through a torch. You know what, I might as well do that right now. That's also gonna give me space underneath the entire machine. From here to here maybe. Also, guys, did you notice, doesn't this look a little bit like a school? Especially from this angle. Like those are the playgrounds in front of the school, that's the school building itself. Maybe it's just my imagination. Yeah, it's definitely my imagination. But I guess now you guys can't unsee the imagination. Right, anyways. Yeah, I'm just gonna implement the clock signal right now actually. Since that seems to be pretty simple. How do I implement it? Just torches running underneath it? Okay, maybe like this. Okay. I'm just gonna place redstone over all of this. Okay. Now I just have to place a target block and a torch at the right place. So it looks like this from the bottom. Oh, here. Perfect. Oh, this is correct, right? Let me just double check. Yes, it is. There should be 8 of these. Yes. I'm just gonna turn all of these off for now. Since now I don't have to manually give the clock signal. These are all the clock signals. These levers are the clock signals that I've manually set to on. But now I can finally have an actual clock signal. I might as well connect it to the input side. Where's the center? Here. Roughly around here. Oh, I should place it a bit more to the left. Here should be ideal, I guess. Hold on. Yes. Let's see how far the signal reaches. Okay. Hold on, it's not reaching all the way. Okay, till here. Now is it reaching? Oh, it's missing this by 2 blocks. Nothing a bus can't solve. Okay, perfect. What about the other side? Is this signal not reaching anything at all? Okay. I'm gonna have to get a little creative with this input. No, this is not good. Or I can just disconnect this bit from the other machine. There you go. Is it reaching all the way till the end? No, it's still not reaching. What can I do now? Another repeater? Seriously? Do I want to add that much delay? Okay, so if I move this by just a tiny bit, it's probably gonna... Yeah, then this one won't be powered and I'll have a repeater for this one. So I might as well just place a repeater here anyways. Now all the clock signals are on. Are they? No, wait. Oh. I can just break these, right? Yeah, because... Oh, I accidentally created a NAND gate and turned one of the inputs off. Yeah, it should work now. So the clock signal is true. The address is connecting to this register. It's connected. Now it's connecting to this one. Oh, let's go. It does work. So now that the clock signal is connected to, what can I do for the input lines? How do I connect them up? Like so. Okay. Hold on, I think I am cooking here. Wait a minute. Okay. Now I just got to do the same for all the other registers. And then I'll have a common input bus. Hopefully. This is probably the longest stream I've done ever. How long has this stream been running? Since 9:30? It's past 11:30 now. Okay, maybe this is not the longest stream that I've done then. Sure does feel the longest. This is an attention span test. This input is connected. Let's connect up this one as well. Oh, I have subconsciously made the exact same pattern. Wow. Except for the first one. What? I just placed a block on top of a torch and connected it. Okay, you saw that. Weird. So I have 4 concurrent viewers. Just another reminder to subscribe, by the way. This computer is gonna be completed in hopefully a few weeks, less than a few weeks for sure. If you wanna see a working computer in Minecraft, built block by block, without any references from without any world downloads whatsoever, then you should subscribe to the channel. Let's see what a noob can do. So I'm just building the same input thingy multiple times here. Oh, I wish I could just clone this bit, but it's too complicated to be cloned. And there's too much to break here. I wanted all this to be simple and elegant, but I guess efficiency took the W here. And it's pretty simple to understand too. It's not like A noob won't be able to understand it. I can explain it to a 5-year-old if I had to. Oh, I missed this input. Wow. What? How is this input going higher than the rest? Oh, because of this one. Now it should be fine. Is this right? Oh yeah, it is. Did I just break the entire thing? Oh. What do I do about that? Um... I guess I'll just cut it off for now. That's not the ideal solution, but if it works, I'm not gonna complain. My second and third monitor are on charging right now. Technically, my first monitor is always on charging. Okay. Alright, last two. Final two. Let me get some music as well. What should I play? This will do. My headphone is poking my ears. Don't take that out of context. I know someone's gonna clip me. Can I connect this the other way? It's gonna say a redstone signal. Seems difficult to do. No, I'd rather not try. Okay, let me... Okay, I was just checking if the volume of the music is right. Let me... should be slightly softer now. Let me make my game sound. Actually, it was fine. Okay, now where can I place the bus lines? I can't place it here, so okay. There's signal going over these lines. I'll see what I can do about that. For now, let's just I'm gonna cut this off. Not anymore. Oh, hold on. This just makes the entire thing a lot more complicated though. Well, that's complicated. I don't know what to do about it. Hold on, this music is too dramatic. If I have a line running from here, I might need a repeater for this. Yeah, I think a repeater would be the smart choice. Okay. And then for the rest I can just do something like, I don't know. Can have this connect through here. Maybe some other way to connect this. That's just gonna connect it to the wrong place then. This is also gonna connect it to the wrong place. Well, oh, like this. Okay. Not bad. Hopefully. Oh. I'm gonna have to block this off for now. This one as well. Why does this music sound a little bit like Terraria music? Right? Anyone else hearing it? Okay, is this... this repeat is not enough. Oh, can I try busing it? How much more signal strength do I need? 1, 2, 3. Okay, busing would not increase the strength by that much. Anything else I can do? No, I just got to place another repeater. Well, it's fine. Oh, I also need one here. Might as well place it right here. So the signal strength, hopefully it reaches all, it doesn't reach all the way. Yeah, I'm gonna need another repeater. If I place this one here, we'll see how far this goes. Oh, close. I suppose. Actually, I can just make it a little bit simpler and place the repeater here. And I can get rid of these lines. Why did the green line connect to the blue line there for a second? Chat, I know what to do for the music. Why don't I just go to Epidemic Sound and see what it suggests for my channel? Ooh, Bitmaster. Hold on. Hopefully I didn't blow up your guys' ears there for a second. That would have been quite funny though. Oh, Epidemic Sound is also ad-free unlike Spotify. Oh, but I am paying Epidemic Sound, so I guess it does check out. Alright, so the first blue input is connected. Oh, I'm cutting off this line now. How do I power this thing without cutting off any lines? Can I just move the line for a second? Maybe like so. Move this line as well. I might have lost track of what I'm trying to do here. Right, chat. Someone came into my room, so I had to mute. Weird story. Anyways, oh, what am I doing? In chat, isn't Epidemic Sound cooking with the music right now? The music is such a vibe. Why don't I just download all these right now? Selected. 3 tracks selected. Download. Okay, I'll do it later. Alright. So the top row is connected. Should have done from top row to the bottom. This has gotten so complicated right now. Why? Oh, hold on. Okay. Let's do it register by register. So all 4 of these are connected. Are all 4 of these connected as well? They are. Are all 4 of the inputs connected? They are. For this one as well. For this one I have to connect the inputs. Shouldn't... I was just about to say it shouldn't be that hard. And then I burnt out a torch. Very funny. I did not do that intentionally, by the way. I saw the torch, but then I wasn't paying enough attention to it. That's the thing. Oh. Right. So it's gonna connect like so. Wasn't that hard. I just got to place redstone here. Oh, this isn't connected, is it? How did I conclude that this was connected? This one is connected, this line is connected as well. This, and so is this. This one is too. This line isn't connected, but luckily this is pretty easy. Okay, this one isn't connected, but I think now it is. Okay, wasn't that hard. Let me just double check. Most likely I missed something. Have I connected the same thing to 2 inputs? Of course I have. How are there only 3 inputs here? I was trying to connect 4 things into 3 inputs. Alright. No. Why is it connecting into multiple things? That's not what I want. Oh, there you go. Wasn't that hard. Can just place this here and this here. Oh, wow, okay. Let me actually double check for real this time. The top connection is connected, second one is, so is the third one, so is the fourth one. Yeah, perfect. Let's look at this as well. What? The connection is cutting off the connection. This is annoying. I'm pretty sure I broke something that I wasn't supposed to break. But we'll see. I'm gonna have to double check all of this anyways. Why is this red? Okay. What are all of these actually connected right now? This is the one that I just connected. This one, let's see. Oh wow, it actually is. And then look at this one. Oh, so is this. Let me give this some inputs as well. I might as well make the inputs a little bit lower just because I can. Oh, perfect. Just the right amount of blocks. Wow. Hold on. That was absolutely of no point. Whatever. Okay. So I can load data onto these registers now. Let me do something like this, and then perfect. Let me set it to night time so that I can see the lamps a bit better. Okay, the clock input is on, the load input is on. What data should I write? Let's write a 1 for now. I've written it to the first register. Oh wow, okay. Why don't I write 0 to every register to begin with? Let's write 0 to register. Let's see, have I written it? Yes, I have. I'm writing stuff to register. Hold on, does that mean that this build is actually complete? Is there anything that I'm missing right now? Oh, I have to place repeaters on this thing. Okay. Let me do that right now. Let's start with the topmost bus. Okay, the signal seems to be reaching most places. What? It already ran out here? Oh, never mind, it did not. Daytime would ironically make the redstone easier to see. Alright, no, the redstone signal ran out. This is a mine. Let's see by how much it ran out. By 3 blocks. Can I reposition the repeater just a tiny little bit? Is that something in my power? I can reposition the torch though. Is it worth it though? That's the question. No. I cannot reposition the torch because then this redstone would start powering the redstone below. That's obviously not a good thing. I hope I did not break anything. I'm gonna have to place a repeater at the very last block. Is there any way to avoid this? I can make the input line a tiny bit smaller. But no. Yeah, I'm gonna have to place a repeater on the very last block. I'll place it here to save. I could also shift all the entire set of inputs a little bit to. Hold on, why did I not do that from the start? It's not in line with the load input. If I can, then I might as well, right? Said a smart guy sometime. Also, why do I have to lower it by 1 block? Can't I just build it like a normal person? Like so? Would it look weird then? I don't think so. Why did the music stop? Oh, the tab must have unloaded itself. No, that's not possible. I'm only at 50% RAM utilization. Hold on, 50% RAM utilization? I'm in Minecraft and streaming, and it's just at 50%. That's a little unbelievable. Considering when I have only my editor open, it goes to like 95%. I'm streaming in. What resolution am I streaming in? 1440, right? Let me just double check real quick. Output is in. What is it in? 1400 kbps? Is it in. Oh, yeah, I'm streaming in 1440p. Very good. That's 2K. Okay. Did I just write something? I just wrote. Oh, what? No. Oh, okay, the repeaters. I have to place the repeaters. That's why I haven't written anything. Okay, so the top bus is complete. Time for the second bus, which would be harder. Yeah. How do I make it shorter by 2 blocks? Is it even possible? I can make it shorter by 1 block, but that's about it. Is there anything I can do about it? No, I just have to place a repeater. Hold on. Yeah, I'll just place it here. I don't even care. I'll place it here for the sake of consistency with the upper bus. Let's look at the other registers over here. Okay, I need a repeater. Here maybe? Can I do something? I'll just place a repeater and see where I need the next one. Here and here. Can I get away with one repeater too? Reduces the visual complexity of the build by a tiny bit. Yeah, that works. Alright, I think the second... What? Did I just do something to the third bus? Yeah. Let's see. You know what? I might as well place repeaters on all the buses in the same places. Just looks slightly better visually. Will I need... Yes, I will need repeaters here. How do I place it here then? Like so? Oh, yeah, that works. I would need a repeater here, I guess. Wait a minute, how far does the signal go? Oh, it can go further than this. Okay. So that means that I'll also need a repeater here. Luckily that's quite easy. A repeater here, here. Alright. Okay, I think all of it should be working. Let me try writing one on all of these actually. So it should have already written to the one at 0 position. Oh, yeah, it wrote 111. That's exactly what I wanted to do. Okay, let's write it at the register at position 1. Oh, okay. What? Why did it write? Hold on. Hold on. Oh, oh no, no, no. There seems to be a mistake with the cloning. Now I have this portion here. The RS NOR latches. I guess I'll just break it down then. Destroy it. You know, earlier I would use TNT to destroy this so that I would not have to break it manually. Do you know how stupid that idea is? It only takes one slightly wrong explosion and all the glass blows up. And then you spend 10 hours figuring out what broke. Speaking of spending 10 hours to figure out what broke, I really should make a backup of all of this. I'll make it later today though. Right now I'm streaming. Okay, I've written ones to another register. They should write it to the fourth one. Oh, no. Why has it not written anything? Let me try writing zeros to it. Oh, that did write 0, but only to the bottom bit. Let's see where the issue is. Probably with these things only. Yeah, it does need a repeater. or rather repeaters, plural of repeaters. Also, the bottom one did get a repeater, but these ones did not. That's the problem. There you go, it should work now. I should be writing ones on it. Why is the torches on these? Better, that's better now. Oh, look at the beautiful orange and blue. The color theme is so nice. I just wrote ones to two other registers by mistake. Wow. I guess that helps me verify that it's working. So last two remaining. Last one remaining. Oh no. Yeah, something doesn't seem to be working in here. Oh, all of these are receiving power. That means something must be wrong with the address then. The address thing must be receiving power from somewhere. This glass tower is supposed to turn off. Oh, I cut this. I cut this line. That's why it's wow. Perfect. Now it works as well. Let's go. Let's try writing zeros to all of them, I guess. Let's also try the load and clock inputs. Let's actually try writing 2 just because nothing written yet. If I turn on the load but not the clock, nothing written yet either. If I turn on clock but not the load. Okay, this I might actually be cooking. I did this bit on... Okay, it wrote 2, nice. I'm pretty sure I wrote this bit either on the iPad or on a piece of paper. That's how I came up with this design. Actually, you know what? Let me check right now. Did I make this on an iPad or a piece of paper? This is my notebook from physics tuitions that I never really used for physics tuitions. Oh, I have more computer science in this notebook than physics. Let's see. Let's look at the pages. There's not much written in here. Did I come up with this inside of the iPad? How did I come up with this idea? Hold on, the RS NOR latch? This thing, the in, load, and clock inputs. That's all done on paper, but oh, so what you saw on stream today was entirely done on the iPad, and the thingy that you saw before that. Let me show you. Oh, you know, this is my secret method of transportation. But yeah, this bit was drawn on paper. I drew this bit on paper and then I shortened it. Yeah, that's the thing. Anyways, you wanna look at my secret mode of transportation? How cool is this? It's a trident with Riptide 5, by the way. Riptide 3 isn't as fast. Anyways. Alright, let's see. Should I try writing 2 on all of these? Just for fun. No, actually, I'm pretty sure I verified that this thing genuinely works. So I've made a clocked RAM module. Alright, let me think about this. Can I just chain multiple RAM modules together? Oh, hold on, this isn't complete yet. If I go to the other side, then I still have to connect up the inputs. The outputs, I mean. The outputs will go to a multiplexer, and then the address should be able to choose which one we see as the output. Yeah, that's still remaining. Okay, how do I do that? For that, the input will have to go down. How do I make it go down without it interfering with the other inputs? Will I just have to make the entire wall of inputs stick out a little bit? Hold on. Okay. Oh, let me just play some music. Why does the music keep turning off? Oh, okay. Is this the same song as before? Let me go to more tracks. Bass. Okay. Like so. Hmm. If I'm gonna be powering this block, oh, how am I supposed to get a signal to go both down and up at the same time? Can I make the signal be level with these other thingies? Can I make all the signals level? Can I do that? Hopefully, I think so. Oops. Just like so. Okay, that's the load signal or clock signal, whatever you want to call it. They're literally the exact same thing internally. And then this is the clock signal, let's say. Clock. And then what am I doing? Load. How do I give this exact same input to two wires? Can I do it? That won't work. Over here, and then if I turn you know what, I'm just gonna make an input on the side like so. Actually, I can just make this input go over here. Now I'm thinking, can I make all the inputs in line with each other? That would be kind of crazy if I can do that. First of all, actually I don't want to break something that's already working. You know what, it doesn't even matter where the inputs are. I'm just gonna leave it as is. Lever over here. Pathway going like so. Okay, I'm running into a wall. I got to go under it. This works. Okay. Oh, should I actually make the multiplexer first? That would be the smarter move, wouldn't it? I should... Okay, how do I do this then? I can have a glass tower for each of these. Hold on, let me think this through. So I can have an AND gate for each of these. How do I do it? Let me turn on the iPad and we'll see. Hold on, how loud is the music actually? I got to check. Okay. So the thing is, how do I make the multiplexer thingy? So I can either have a tower. Okay, so this is the not input. So this is gonna be on. I mean, this is the not output. So whenever the actual output is... Okay, no, actually my bad. This is... Yeah, this wire, this redstone dust has the same output as this torch. So if I want to not it, I can just place a torch. Oops, no, I have accidentally written something to this. Let me unwrite it. Easy. Okay. How do I do this? Yeah, why don't I just make a very simple AND gate? So I have to use the NOT of this input, which is actually the same as this one. So if I can intercept this line, this is the NOT of this. And then if I have a torch tower, actually, you know what? I should clone this so that I have a backup. I should also do a world backup sometime soon. Today, I mean. Alright. How low is this going? Very. Okay, perfect. So these are the limits of the build. Clone here to... Oh, overshot it. Again? No. I'm not good with projectiles. Like so. Clone from there to there, and the place where I'm gonna clone it would be... What? I'm gonna raise it in the air a little bit more. Okay. Looks pretty good, I guess. Actually, let's do a quick world tour. Let's see how much I've built. Let's start with the very basics. This is just testing stuff. Then I built all of these. Oh no, wait, look at the progression. I don't think you guys see it just yet. This is an RS NOR latch. All of these are just the registers. Then I'm stacking these bit memories, and then I have this thing, the entire RAM thing, and then I made it even better. Huh. Let's have a look at the ALU side of things. Okay, so what is this? Oh, this is a 4-bit adder. Also, 4-bit adders. That one I attempted to make an ALU on stream, but I don't know. I needed a little more time to plan it out, I guess. Hold on. Okay. And then this over here, what is this? Oh yeah, I was testing how to make a really compact adder. I believe it is this only. Look, that's an XOR gate. That's another XOR gate. Hold on, is this what the entire ALU is built on? I think so. Yeah. And then look, I added these input gates to the ALU. Then I made it 16-bit. And then here I also have the output flags too. Let's go back to where I came from. Perfect. Oh, overshot it a little. So, okay. What do I do now? I have to build a multiplexer now, which is really easy, but also it's easier said than done because I have packaging constraints here, which I don't have on paper. Speaking of paper, let's see if my... Okay. Let's see if my Apple Pencil Pro charged finally. No signs of life. Yeah, it's still at 0%. It's literally been charging for 4 days straight. So, how much would that be? 96 hours? Okay, let's think of this. This is an input. Let's just assume it's 1 input instead of 4 inputs. And then an AND gate. I can make this better. An AND gate. Here is a condition. So when the condition will be met, it allows... Actually, you know what? Why don't I build this in Minecraft lingo itself? Here is the AND gate. Don't mind my pencil just being a little jerky. It's the Apple Pencil noob. Not even Apple. So, what is the condition in this case? You guys can see the whiteboard, right? Let me just Let me just build a black background. Black concrete. Alright, now I can explain in peace. Let's have the redstone in the background a little, so that any new viewer that joins in knows exactly what's going on. So, alright, so this is gonna output only when the condition is met, and the condition goes through here. What is a condition? Oh, it's multiple conditions, isn't it? How do I do that? So it would be an AND gate, right? Something like this. And I have to OR multiple gates together. I mean, I have to OR multiple inputs of the address together. So these three are the address. Actually, I shouldn't call this in. This isn't the in. Technically, it's the out of the multiplexer. I'll just call this the data D. And then I have three of these addresses over here which need to be 0. When they are all 0, this OR will be 0. Then the NOT gate here, this will turn it into 1. 1 will go into this AND gate. So far so good, and the data can go straight through. Okay. So I can remove these two NOT gates. And my data actually already gives a NOT gate. Alright. Actually, I already have B not present. So I might as well use that instead of this. So this is too much scribbling. I won't be able to read it. Alright, let's start building it. So I said building, not breaking. I just broke the blackboard. Hold on, this is so hilarious. This is something every student dreams of doing. Wow. Okay, so here are the addresses. I'm gonna make them all run down from underneath the entire thingy. How do I make the signal go down without interfering with the one next to it? That's a challenge. Isn't everything a challenge in Redstone? If it were easy, then it would be something that anyone can do. Well, technically anyone can do Redstone. Alright. How do I have this one connect to this one but not that one? Could block this off, but that would be against the very point. Maybe I should connect this one first and the answer might dawn upon me. No, there's the clock input in the way. I'm just gonna move this a little. Gonna make this 2 blocks away from the load and 2 blocks away from the other inputs. The signal strength is surely gonna run out now. I'm just gonna place the repeater and call it a day. Like this, and well, that's not very efficient, is it? But I'll make it more efficient later when it's actually working. I wanted to be efficient from the ground up, but I don't wanna be nitpicking when it's not even ready, if you know what I mean. Alright. This input... oh no. This entire thing has to move. Because there's gonna be an input in the way. Alright. Seems fine. Okay. Oh, I did not have to move this. Whatever. Moving it only made it simpler. Oh, no. It's fine, I'll just move this out of the way of the torch. Right, so chat. Y'all watch YouTube, right? Of course y'all watch YouTube. Today I saw a video. It was from a YouTuber. Yeah, basically it was a redstone video. But ironically, the guy wasn't very good at redstone. It was so funny to watch. It was almost triggering. You know what I mean? Cause he just built something completely obnoxiously wrong. And I was how do I say it? I was basically flinching to see it not work. Okay, the green input is getting in the way. Can I just move it like this? Okay, I might need to... oh, did I just... Okay, if I turn it off, it stays off. That's what I want from it. Did that make enough space for anything? What am I connecting it to now? That did nothing. Maybe, okay, did something. Oh, wait a minute. Okay, no. Okay, so the top line is connected, but the bottom line isn't. How do I connect this then? Repeater, that would be the easy way out, but it's also the least efficient way out. Can I just... hold on. Can I make this drop a little? No, I cannot. How do I do this? How do I make the bottom line connect from the top one? If I turn this into glass? Oh, wait. Have I actually done... Oh, let's go. They're connected now. Wait, was it that easy? It is that easy. I might as well... Oh. Okay, now I see the problem. Can the problem be diverted a little bit? So this is being soft powered. Okay, the repeater. Will it get in the way of something? Oh, okay, it will. So We can't have glass here. Yeah, that sucks. I can... Oh, here's something that I can do. What? Did I just get stuck holding the shift key? Okay. Well, I really hope I haven't broken something that already works in favor of a minor cosmetic upgrade. Oh, this is the stuff that I don't want to do. I don't want to accidentally connect lines and then be debugging why it's not working. I'm gonna be solving all sorts of those Boolean equations, wondering why it doesn't work, only to see that I've connected two lines together. That's the sort of thing that I would do. Alright chat, who are these two concurrent viewers? Actually just one concurrent viewer. Oh. Oh. My friend is messaging me, but I'm in flow state right now. More like I'm just locked in because I'm stuck in the stream. I don't want to stop streaming is the thing. My Discord overlay doesn't get shared, right? Okay. Why did my taskbar pop up? Anyways, let's get these wires. And then hopefully I can think about what I'm thinking. Hopefully then I can see what I'm thinking about. And then I can think visually. Rather I can think more visually because I can already imagine stuff in 3D. So not like it makes much of a difference, but then I can think about what I'm looking at. Just to make sure that is 1, 2 and 4, right? Oh my bad, this is 1, this is 2, this is 4. 1, 2 and 4. Oh, that's what I just said actually. 1, 2, 4. I'm gonna place signs to solidify it. Wait, 1, 2, 4. That would be the exact inverse of what we have over there. 1, 2 and 4. Oh, perfect, okay. Obviously, I'm gonna need repeaters as well. Where will I need them? Here. I can just bust this bit for slightly more redstone signal strength. Like so. That does it. I'm gonna place a bus here. I have no idea why they're called buses. Who named these things buses? I can increase the signal strength just like this. Where's the signal strength in here? Oh. I need to bust this? Here? I can't increase the height on this by a little. Okay, I need to bust this right here. Alright. I have the inputs ready. Here they're all... Okay, this is pretty good right now. They're all at the same signal strength. One less thing to worry about, I guess. And what we have here. Okay, I'm gonna draw this. Okay. Yeah, this is the diagram. Oh, I already have it drawn. What was I thinking? So I'm gonna take the lot of data. Just gonna break these lamps. Just because. This is the knot of the data. And then I have to take it into an OR gate.
KD said app.quilgo.com.
Oh, then the narrator is gonna ruin that. Okay. Quilgo. Whatever. Let me switch to my OpenClaw. Oh, chat, should I make a video on OpenClaw? Okay, so I need... So this needs to go onto an OR gate. This is a diode. Why don't I make this right here? That will be so much more compact. Alright, here are the diodes. Something like this should work. And I'm gonna color code this bit as well, even though most of it's glass. Oh, wait. This will work, right? So the signal from the glass can travel up. Oh, wait a minute. So what I don't want happen. So what I do not want from happening is the signal from this thing. This is the not output. I don't want the signal from jumping over this glass and into this glass tower. That's not gonna happen though. That's not something that I need to worry about, luckily. Okay, you guys are seeing the green thing in the bottom left. I do not like it. Should I just keep my iPad unlocked? Actually, you know what? I'm gonna open it anyways to see how much battery it has. Might as well keep it open. Luckily the password isn't shared. That's good. Okay, looks good. Nice, so far so good, I think. So we have this glass column here. What does it do? I don't know yet. We'll find out. We have signal here. Torches here. Okay, right now it's giving the exact same signal as a thingy. But can we just block it up? Oh, I think, yes, this is gonna be so cool. Nice. And what's gonna input this one? Those things. I think I'm gonna have to build another multiplexer now. Hold on, it's a decoder. What's it called? Yeah, I think. Oh, yeah, decoder. I'm gonna build a decoder using these three as the inputs, and then the output goes into this thing. Oh, I did not know if you spam space and shift together, you exit fly mode. Oh, okay, I did not know that. In my 10 plus years of playing Minecraft, this is... No, actually I remember quite long ago I pressed shift and double tapped space and I was just as surprised. I remember now. Alright, so how am I gonna get these three inputs? Okay, actually for this one this is quite simple. I'm just gonna take all three of these and then throw them into one block. This is 4 to 1, right to left. So if I use this as a glass block, the signal will be able to go up but not down. That's perfect. That's diode technology in Minecraft. Very cool stuff. Actually, I might as well turn this into a glass block just because I can. And then I merge the signal. Actually no, do I... Oh, I know. This is what I've been meaning to do. Glass block here, which feeds into this. So this glass block acts like a diode. Okay, and then so does this one. Oh wow, that's perfect. And then the third input line will be coming from here. Redstone wire. There you go. All the lines connected up with redstone. Let's see where the signal runs out. Right here. Here. And here. Okay. Oh no, the signal strength runs out. One sec. Oh wait, I'm gonna need a repeater here as well. Oh, because the tower... okay. Because the signal from those repeaters isn't able to reach here and power this tower. power this tower. Yes. Hold on, I don't even... Okay, never mind actually. Scratch that. So the signal can't even reach here. How am I gonna do this then? Can I perchance make all these connections meet a little earlier then? Maybe like so. Then repeater here. How much can I take from this connection? Alright, so this is an OR of these two. Logical OR. Repeater this with repeater that. Hopefully this works. Repeater this with repeater that is exactly what I would say. Is repeater this reaching all the way? It is! Nice, and is it capable of... Oh, it isn't reaching all the way till the top. Or is it running out by 1? What? No, let me see. Is this power? It is. Okay. The signal strength is running out by 1 block. Oh, I can just bust this. Wow. That's an easy fix. Oh, let's go. It does work. Repeater this, repeater that. Perfect. Okay. So this entire stream has basically gone to building this RAM thingy. I really hope it pays off. How long in the stream? How long have I been in the stream? It started at 9:30. Hold on. 3 hours. 3 hours after 9:30 was 12. Okay. So 3 hours 45 minutes. I've been streaming for 3 hours and 45 minutes. This is quite the attention span test. Why do I have exactly 100 subscribers? No one else subscribed? Whatever. Let me see if I have any notifications on FixoGenie. Alright. Chat, I got a comment. Can Redstone do 4K rendering? If yes, then prove it. My PC can't do 4K rendering and it has a 3070 Ti. Actually, no, it can, but it's still very demanding. Okay, so here. So this is what I was doing. If all these inputs would be 0, oh, then I can use this, okay. Then this glass tower would turn off, and then this input, this would be connected to the output. Makes sense, yes. Oh, wait a minute, I should have gotten these lines from up above. But how though? It would have ran into these blue wires. How could I have done that? Now if I place torches onto these wires, then the output would be coming from below. How big can a glass tower get before the signal runs out? Let me test it right now. I'm sure there's a way to do this mathematically, considering signal strength is 16, and if you hard power the bottom redstone, then it can reach higher. Hold on, glass towers are pretty powerful. Okay, glass towers can reach quite high, but the thing is also that we have this torch over here. Not too bad though. Has potential. With the right torch setup and all that, I can see this working. Okay. I was thinking to not overthink, but also I should be planning. How do you spot the difference between planning and overthinking? Especially in redstone. Redstone is what I'm concerned about. This also applies to real life, but did someone say life? I don't have that. What does life mean? Anyways, torch goes here. And then glass tower here. Can I make this shorter by any means? Actually, I cannot. Oh, hold on, where do I place the glass tower now? Do I have to place it in the way of these lines? Okay, I'm not looking forward to doing that, but if I have to do it, then I guess I'll do it then. Oh, no. Genuinely, where do I place this tower? It's literally in the way of this line. Let me see when I started streaming. Okay. I almost broke something. Okay, let me think about where I can place the glass thingy. I have to place the glass tower, but I do not know where to place it. There's no place for it to go right now. Yeah, I think I'm gonna have to move the address lines actually. Yeah, that seems to be the only option. It's gonna be a lot of work. I'm gonna have to redo this as well, but whatever. Bye, I guess. Okay, maybe I don't have to build two address lines. I can just connect this one, connect this to this, and then build one more address line like so. Alright. What do I do for the signal strength not reaching all the way? I could bust this. That would increase the signal strength till here maybe. Okay. So if the signal strength can come till here, I place a target block here, repeater here. Yo, wait a minute. Is this the... wow. Okay, no wait, there's some extra delay because of this repeater too. That's kind of the thing. It's fine though, right? Is this how I'm gonna place it? Like so? This is not very efficient. I do not like this. So we have a signal coming from here. Can I just connect these somehow? Okay, I can have this powering this here. This redstone can power into this block, which powers the glass tower. And then we can have this line powering the rest of the tower. Let's see if the signal reaches till the top. Okay, it's short by 2. How do I fix that? Do I just place another repeater? That would be wasteful. Alright, this does power this thing. Oh, wait. I can power higher into the glass column though. Oh, wait, does this. Let's go, this does work. So, all of these two. This as well. Okay. Low key, I might be cooking. Okay, this was the hardest input. I hopefully. Now, genuine question, where do I place the glass column for these ones? Right here? Is this a good spot? This will do. Hold on. How will I make sure that the signal doesn't travel from... Oh, it can travel... Signal can go from here onto the glass tower. That doesn't sound like... Okay, I can build it here actually. Maybe like this. Okay. And then now, how do I power this tower? See, first, this is gonna be regular glass, regular block, like so. Oh, you know what? Let me go ahead and input a number here. Like what? 1. So the register at first index, which would mean, oh, this one got disabled. Perfect. This should be 0. That means it torch on this input repeater on these two, torch on this address line and repeaters on these address lines. Okay, and I'm gonna have to place another repeater. Okay, that's fine though. Oh wait, this is gonna connect, okay. Alright, this should work. Okay, now I just lay a very simple connection from underneath with a repeater here. Hopefully that gives enough signal strength to power this entire glass line. Alright, and then I go above these repeaters just like so. What? No, this isn't supposed to power this glass from here. Oh, I can just cut it off. Wow, that was easy. Chat, y'all won't mind if I grab a snack, right? Haven't eaten anything in 3.5 hours. Oh, what's XP in the chat, by the way? Fan. Oh, let's go. Top fans. That's so cool. So, people in the chat get XP. I'm curious, who are the 3 concurrent viewers right now? So guys, if anyone tuned in right now, as you can see from the title, I'm building a computer in Minecraft. Let me show you everything that I've built so far. That is a working 4-bit ALU, so you can do addition and subtraction using this machine. And then what I have over here, these are all of these memory modules. So they have registers and essentially you can make RAM using them. And yeah, this is what I'm working on. Here I have 8 registers, and essentially you put in the address of which register you want to choose, and then you can either choose if you want to set some data to it or you just want to read it. So this is the input for load or write, and then here's the value that you would want to write to the register. And then here I'm working on, so these are the address lines. I'm working on a way that you can choose which register you want to read, and then it would give the data from that register to you. How am I still running out of signal strength? There's literally a repeater at the bottom. What else can I do? No, like genuinely, what else can I do? Let me see how far the signal strength is reaching. How do I see? The new F3 menu is so weird. Can't even read it. Maybe that's just a yeah, that's definitely a skill issue. Okay, this one is powered, this one isn't. Alright, so 2 blocks, okay. That means I probably actually have to power this one. Can I actually use torches? Hold on, that might be the new meta. Yeah, wait a minute. So that means that I also have to invert the things that I'm using. Invert the whatever. So in place of repeaters, I'm gonna use torches, and in place of torches, I'm gonna use repeaters now. Repeater, torch, redstone, wire. Okay, looks good. Wait, no. That's not how it works. Oh, I completely forgot De Morgan's laws. So if either of these okay, that is not how De Morgan's laws work. It's 1:35 a.m. right now. That's why my brain is not working. This would have been easy work for... I'm not including this in the video. Alright. That is fine. This is not fine. I got to find some way to give this redstone repeater thingy. So this can be soft powered, but the question is how. Like this. Okay, that could work. I could just use a normal block, and actually a target block is more intuitive. You can see the redstone going into it. Alright, let's see if the torch can... Let's see how far the signal goes. Okay, all the way till the top, that's completely acceptable. Fine with me, if it works, it works. Let's do the same for the other ones. Okay. Maybe like this. Hold on, why don't I just have the output right here? Why go an additional block for this? No, genuinely. I don't know. I've already started this thing. I think I've found a way to make it work, so I might as well stick with this one. Chat, genuine question, who are the 3 viewers? I really wanna know who's watching my stream right now. Oh. Alright, so like this. I just stood on the glass block by mistake. Whatever. Alright, so... Wait, no, this does not connect. How am I supposed to connect the glass to this thing? Maybe like so. This works. Does work, I guess. This. And this should also work. Oh, but this, okay, this would work better actually. No, it doesn't, it wouldn't matter how. It wouldn't matter at all. Actually, why have I not thought of this yet? This saves so much redstone signal strength. Oh, never mind, I did think of it. Oh, I would not have had to place a repeater. Oh no, never mind, I will still have had to place a repeater there. Okay, chat, I should probably be leaving. Oh wow, all my concurrent viewers just left right when I was about to. As soon as the stream reached 4 hours. Okay. You had 7 concurrent viewers. Oh, 23 views on the stream already. That's insane. Anyways, chat, I'm genuinely gonna head out now. I have to sleep. I should eat something. It's been... Oh, it's been 4 hours and 15 minutes since I last ate. And this has... I haven't taken a single break in the past 4 hours and 15 minutes. Alright, chat. Wait a minute. Have I been streaming for 5 hours? I started at 9:30. I started at 9:30. 5 hours will mean that I have to stream till 2:30. That's not happening. Actually, chat, I'll take a quick break. I'll be right back in some time. I should write that on the screen maybe. Just like this. With the music playing and all. I'll be right back. Wait, I have 3 concurrent viewers again. Who are you guys? Do you wanna reveal your identities in the chat maybe? I'm genuinely curious. I just had the live page open while I was eating something, and the average view duration is 40 minutes. Wow, that's genuinely impressive considering my average viewer actually has a life. I might genuinely stream for 5 hours just because I can enjoy this. Anyways, I'll be right back. Yo. Oh, let's go. It's my friend in the chat. Yes, I am live at 2 a.m. I might genuinely continue till 2:30 a.m. just because I can. So, Cam, let me just delete this text from the screen. Alright, I am back. I do not know if it has been 5 minutes or not, but I can continue building this thing now. Let me just... okay, made space on my desk. Why do my concurrent viewers keep going up and down like a roller coaster? Whatever. I'm getting to stream, that's fine with me. Alright. Actually, I'm just gonna use this thing. I'm just gonna build the glass tower right here. It's more efficient. Can the signal go from here onto the glass tower? Oh, it absolutely can. That is a small problem. How do I fix that? Oh, I did not see that coming. Well, if I place a block here... okay, I might be cooking. Wait, Okay, no, it does work. What's in the music actually? Has the music quality just gone down? Uh, I should refresh this and see what epidemic sound recommends to me. This is the music that was playing sounded like the music that you would hear at I don't know, a clothing shop. I mean, no offense to the music, but uh, just in the mood right now, I guess. Okay. So now we have. So we need repeater there, torch here, repeater there. I'm gonna place the repeater backwards again. People are gonna cringe at this, but what else can I do? Oh, hold on. How do I take the signal, put it, make it jump above the repeater, but not have the repeater power itself? Okay, wait. What if I just place the repeater in a different position? That should work, I guess. Like right here. No, that's not a good place. Oh, you need to catch up on day 2 and the 4 hours that you've missed today. Oh, that would make sense. Let me just catch you up real quick. So in day 2, what did I do in day 2? Oh yeah, after day 2, most of the stuff that I did was off camera. It was mostly just optimization stuff, one thing after the other, but essentially on day 1, I built this 4-bit adder. Oh, I think you might remember. I built this 4-bit adder, and then after that, I believe I just made the 4-bit adder more concise and whatnot. And on day 2, I really did not do much. I explained how the ALU will work. ALU as in the arithmetic and logic unit. And then you skip ahead a bit of optimizations, a little bit more work, little bit more work on top of that. And then you have this. Now, the way that this can do addition as well as subtraction is really interesting. So right now, actually, you know what? Let me use the other model to demonstrate the previous one, since it also has the lamps for the outputs. Yes, these ones. Let me reset everything real quick. So obviously this is based on the adder. So you can do 1 plus 1 equals 2. But what this lever does is that it ANDs these two. So 1 and 1. That's what it does. So if I do 1 over here, 3 over here, then it only gives 1 over there because it's ANDing these two. Also, logical AND as in this should be 1 and this should be 1, so it gives 1 over there in binary. And then when I turn this on, then it does simple addition. 1 plus 3 should be 4, it gives that in binary. That's 1, 2, 4, 8. Now I can also do subtraction, and the trick behind that is really cool. Let me do 5 here and 3 here. So I can negate all of these. So 1 will turn into 0, 0 will turn to 1, 1 into 0, and 0 will turn into 1. and then I can negate the answer as well. So it's adding 1010 to this number 0011, which is 3 in binary. It's adding them, and then whatever answer comes, it's gonna negate it as well. So we are getting 1, 2, 4, 8, and only 2 is on. That means the answer is 2. Let's see if the math checks out. This is 5, this is 3, 5 minus 3 is 2. So this is our ALU, arithmetic logic unit. It also has a couple other things, like it can make this input 0, so that's gonna be helpful if you want to just negate this thing or do some other operations. But yeah, that's the arithmetic logic unit. And it also has these flags. So this flag tells us if the answer is 0. That's literally all it tells us. And then there's another flag which tells us if the answer is negative. So if I add so the answer right now is -1. It tells us that it is negative. This is the other flag. It tells us that the answer is negative. Anyways, here's what I've been doing today. Very nice mode of transportation, I know. So, okay, yeah, so this is an RS NOR latch. Let me just oh, I have one over here. Perfect. So what this does is that these are two logic gates, and this is the output of the first one, and this is the output of the second one. So they both essentially feed into each other. Obviously that can cause these logic gates to get stuck, but that's exactly what we want here, because this is actually a memory chip. We want it to remember something, and the way we do that is by getting it stuck in a state. So if I turn this on, the lamp turns off, and I can also turn this off and the lamp will remember to stay off. And then if I turn this on, the lamp will turn back on, and the lamp will remember to stay on. So this circuit is called an RS NOR latch, reset set NOR latch. So then what I've done is that I've added another layer on top of that. So generally these have a clock signal. Like your RAM has a clock speed, right? It goes 1010, the clock goes 10 really fast. And we want this RAM to only work when the clock is 1. And then here we have the load. So if you want to write something on the RAM, only then it's gonna write. If you only want to read it, then you wouldn't want your inputs to mess with the current reading of the RAM. And then obviously this is in. So currently the lamp is on, it remembers to be on. You can give it whatever input, it will remember to stay on. But if you want to load something, you turn on load. And then when the clock will be on, then you will be able to write to it. And then whatever you write, let's say I want to write a 0. When you're done writing, you can turn off the load, and then it will remember to stay off. No matter what input you give it by mistake, it will remember to stay off. Yeah, that's it. And then I just stacked this very thing 4 times, and now I have a register. So this can hold 4 bits of data. So like we have a byte which is 8 bits of data, 4 bits of data is called a nibble, like a small byte. That's really funny piece of trivia. So yeah, then. So yeah, this thing has 1 input for the clock, 1 input for the load, and then 4 inputs for each of the bits that we want to save the data to. And then I just clone this 8 times. Now the purpose of this thing is that we can select which register we want to use. So all 8 of these are registers. We can choose one of these registers. So suppose I want to select the third one. I'm gonna choose 2, and then the third register is chosen. It's at index number 2. This is 0, this is 1, this is 2. So this is the third register, and I've chosen this. So now if I want to write something, I'll turn on the load, and then I can write something. So the final version is all the way over there. Let me just hopefully not miss it. Close enough. So if we want to write some data, we can use these levers. Let's say I want to write, how much is this? 10. I want to write 10. And then I turn on load. I want to write it to this register, the one at third position. So then, and then I select the data that I want to write, I select the position that I want to write it to, and then I turn on load, and when the clock turns on, then I'll be able to write it. And as you can see, this says 1010, exactly what our input was. 1010. And now I'm working on how we'll be able to read this. So say you don't want to write something, the input doesn't matter when you're not trying to write something. So now I want to get the output of all of these, all 8 of these registers, combine them into one place, and be able to choose which register to read from. So these are all the address lines in yellow, the one where we have to give the address. And now I just have to select them. Now I have to select the correct register. That's what I'm working on right now, which has proven to be more challenging than I was anticipating, but it's fine. I can take a bit of challenge, I guess. Oh, oops. So yeah, I don't know what else to say, but actually I'm doing this in Minecraft because I find it mind-blowing. Yeah, I'm a computer science student pursuing computer engineering in college, and I literally just thought that this would be a fun little thing to do. It's mind-blowing. Oh, hold on. How am I supposed to place a torch here? What am I thinking? It's fine. I'll just place it here, like so. A little bit of diversion. Oh, I can just place it here. Nice. So I want a repeater on that line, torch on this line, and then a repeater on that line as well. Seems simple enough. Should be straightforward. So the wire goes from above the repeater, but the repeater also gets the signal strength, also gets signals from this block, and then it powers this. What's in the music? This is such random music. Anyways. Okay, now I want this to power maybe a repeater or something so that it can power this block, I guess. Where do I place the repeater for this? Hold on. Oh, there's a torch here too. As if it wasn't complicated enough. There's hardly space for me to walk in here. Alright. Okay. Oh no, the repeater is powering itself. Okay, I can just take this down by a little. Perfect. Alright, I think... Is this one connected as well? Let's just try. Let's see how far the signal can go. Torch. Oops. Okay, so the signal is able to... Oh, the torch tower isn't even complete. Why do I keep saying torch tower? It's a glass tower. Torch towers are old ancient pieces of Minecraft tech. Oh, let's go. It does work. In fact, I can get rid of the old output mechanism. I'll connect all of these outputs together. Hopefully soon. You know what? I might as well do it right now. Okay. Okay, so this is the first output line. Hopefully I don't run into as many problems with this. The blue lines at the input were so brutal. Look at these lines, they're going all over the place. Hopefully the magenta lines aren't as much of a problem. Okay. Now I'm gonna place redstone on this. Let's see if this works. I'm just gonna do a quick test with the first 3 registers. Let's see if they can actually pull data. It would be so extremely cool. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So this is barely running out of signal strength. Actually, you know what? I don't even need to place repeaters. I'll just place the output lamps here. Copy my current coordinates. Go over to the other side. Copy my coordinates from here. And then I can just teleport like so. Okay. Let's write 0 to all the registers to start. 1, 2, 3. Oh, 0, 1, 2, that's all I had to do. Okay. What am I reading? What am I reading? I shouldn't be reading anything? What? No, hold on. It's connected to the one at index 1. What? How? I've definitely done something very, very wrong here. What? Wait a minute. This is repeaters on all 3, torch on first one. The math does check. Oh, because I forgot which input was which one. This is 1. This is 2. This is 4. Hold on. Wait a minute. So I'm connected to the register at index 1? No, I'm not. Something's powering this. Something is powering the address lines. Oops. I placed a debug torch there. It's still there, I guess. Forgot to remove it. Silly mistake. 1, 2, okay. What's it outputting? Why does register 0? What's this? Oh, it's supposed to be there, okay. I'm a bit skeptical of everything right now. So register number 0, I'm writing zeros to it. Why is it not outputting all zeros then? Is there something very obviously wrong with it? There must be. Okay, I'm writing all zeros to it. That's for sure. What happens if I look at it while writing zeros? Oh yeah, I'm looking at it while writing zeros. All these torches are actually on. Let me go into spectator mode for a better view. So this is off as it's supposed to be. Can I spot where the problem is? Okay, this is the second register. The second bit of the register, I mean. This torch is off. Why is it receiving power from here? It's giving power to here. Can I spot where the problem is? I'm sure it's gonna be something really stupid. I can already sense it. Alright, why is... Hold on, should I... What? So this is 1, so what is it doing then? Oh, no, I genuinely cannot understand what is supposed to be happening here. Just slow my camera a little bit down so that I can see better. Yeah. Anything broken here? Something is definitely broken inside the registers, but I can't tell what it is. Right? I think something has to be broken in the registers for this to happen. Does this have to be receiving power? I'm gonna try another register and see if I can see if it works or not. What? Oh, this is even more obviously broken. So I'm writing 0 to it. Hold on, do I just have to refresh it with the clock a few times? Let's see. No, of course not. Uh, what's broken? So all the inputs are on right now. Hold on. Can I simply just... Have I simply just taken the wrong output? Could that be possible? That doesn't seem too unlikely. It seems like something I would have done anyways. Let's see. Oh, hold on. These would be outputting true actually. No, something is definitely wrong with it. What? Wait a minute. When I'm writing something... Oh. I am trying to write something, but... Oh, it isn't... The problem is that it wasn't even writing. The repeaters ran out. No. How does that happen? I didn't even reposition this thing much. I literally just went a few blocks down. Yeah, I knew it would be something really stupid. How much more stupid can this be than the signal strength running out? Let me bust this. Okay, the signal does reach far enough. Very good. So now I can write zeros into both registers. Alright. Okay, zeros have been written. Can I see the output of register 1? I think I can. Register 2. Register 0, I've probably already seen this. Okay, let's actually write something now. What should I write? 5. Let's write 5. I haven't written anything yet, so obviously there's no output. Let's write it to the 0th one. It says 5. Oh, let's write 6 to the next one. Alright, I'm gonna load it. Oh, hold on. Why? Is it not doing anything? Register number 1. I'm trying to write something to it. Let's see why it's not outputting anything. This is not supposed to be... This glass tower is not supposed to be powered right now. Okay, wait. How is it powered? Where is it? Oh. Where is this receiving the power then? Okay. Oh, I understand the mistake. Okay. This solid block needs to be here. What? Wait, then where will I... Oh, I know what to do. Okay, there you go. Problem solved. Yes. Now it's giving 0. Oh, it is 6. Let's write 7 to the register number 2 so that I can finally do 6, 7 as that comment said. Yes, I read all comments obviously. 7 to register number 2. Perfect. Now can I finally do 6, 7 in Minecraft? Let's read the value. Let's just put 8 as the input to prove that the input doesn't matter. We can see 5, 6, and then 7, 6, 7. Alright, there you go. There's a 6, 7 in Minecraft. Hopefully you enjoyed it. That was so goofy. I did enjoy it for sure. No, I did actually enjoy it. No sarcasm. Anyways. So, okay, that does work. That is reassuring. I guess now I just... Oh, that's just 3 done. I have to do it 5 more times. Okay, I've almost been streaming for 5 hours. I genuinely do not think I can stream for much longer. Okay, so where should the signal should jump over this? Just like this. Where do I place the torches and all that for this one though? That's the question. The repeaters and the torches, where will they go? Where will I place the glass tower then? Oh, what? Okay, hold on. So I place glass here, this thing here. Hold on, how long have I been streaming? Let's see. What? I'm 2 minutes from 5 hours. What? I'm 1 minute from a 5-hour stream? I thought I was streaming from 9:30. Like at least after 9:30. Well, I can't stream for more than 5 hours genuinely. Can't be good for my health. Anyways. Let's not get too distracted. We have redstone to do at hand. If I won't do it, then who will? Like so. We have the diodes ready. Why is there only 3? What happened to the 4th one? Oh, I forgot it. Alright. This seems fine. So far, so good. Oh, genuinely, where do I place the glass tower when there's all this stuff going underneath? Like, genuinely. Will the signal even reach till the very top? Oh no, this isn't looking very good right now. This will just be, this output will be able to power this thing above it. That's not very good. What's in the music again? Let me just, it's fine, the music doesn't matter. The question is, how did I manage it here actually? That one red block, what's it doing? Okay, I know. I think. So there's redstone here, but I don't want it to jump from this block to this one. So I just blocked it off. And it can't go over glass because some transparent block mechanic that doesn't really make sense, honestly. Okay. Oh cool, okay, I'm just gonna be relying on this mechanic then. So I'm okay. Oh, this works. Nice, I can actually have a glass tower now. Hold on, how will it connect then? What am I doing? Oh, it will connect from the lower one. Perfect. It does work. The glass piece underneath it. Like that. Okay. Where's this glass tower going? It's just gonna run into these lines. Yeah, look. It's not supposed to do that. But also, where else do I put the glass towers then? Is there anything that I can do? Repeater here. This one can be a solid block. But how? If I power this with a strength of 15, does the signal go all the way up? Oh, it sure does. I accidentally wrote something to the register by hand. How do I unwrite? Okay, there you go. Wait, where did the music go? I must have done something. Let's play song. Okay, the signal does go all the way up. That's good to know. How do I power this though? That's the question. Okay, I can power this block, I guess. Wait a minute. Okay, so I've cut this signal off. Can I uncut this? Oh, hold on, okay. That works. Wow. I've just rerouted the signal into a slightly longer path. I think I can bust this one though. There you go. Okay, that repeater has been busted. Now I'm gonna have to block this one. Run some redstone like this, I guess. Oh, this is gonna have to go all the way down. Just like so. Oh no, wait. How am I gonna do anything at this place? In this part of the redstone? Oh, it's fine, I'll try to do something. Let's see. So, I'm dealing with the third register, the one at index 3. Torch here, and repeater here. The question is how? I think I can place the repeater backwards here as well. Okay, backwards repeater is a genuine strat. I wasn't expecting that. I've used it thrice. Just one more like so. There you go. If this input were to be on, just like so. So now are we able to power this entire glass column then? Wait a minute. How is this receiving power? Okay, now that's better. What even is this? What does this connect? Oh, I cut off a connection. Oops. Well, okay, it does receive redstone strength all the way till the top. Let me break this then. Alright, how do I reconnect these without connecting the wrong things? What even is this? I can just make this go a little lower over here. Now the signal can go right over it. That's not an ideal way to solve it, but it's gonna work for now. Hopefully it works forever. I'm just gonna get the third register connected, and then I'm genuinely gonna go to sleep. I'm curious, who are these 3 concurrent viewers that are still viewing? My average view duration is above 40 minutes. Wow. shout out these guys. Alright, so this bit is working. Yep. Do I just go ahead and connect this then? I think it should work. If it doesn't, then I'll crash out. Oh, it's almost 3 in the night. It's soon gonna be 3 in the night. How do I connect? Okay. This is not gonna work. Actually, I can just extend this a tiny bit. Will this power the redstone at the bottom? No, it won't, luckily. Can it still... Okay, let's go. So, I've connected up this one as well. Wait a minute, but this might get in the way of the other one. No, the magenta wiring is getting almost as difficult as the blue one. Well... What else can I say other than I have to do it anyways? What? Wait a minute, this isn't drift funk, is it? What you're hearing isn't drift funk. I literally searched for drift funk. I think we can just agree that Epidemic Sound's algorithm is nothing compared to that of Spotify or YouTube. Is the background music even audible now? What's powering this? Oh, am I giving it a signal of 2 right now? I must be giving it 2 right now. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need to reposition the output lamps. I am giving it 3, so it should be connected to the 4th lamp. But it is not. Oh, why is this not receiving the line is broken. How does this happen? This is the simplest part of the entire thing. Let me try reading the 4th one. It should be 0. Let me try writing 2 to it just as a test. I've written 2 to it. It should still be that. Have I written... I've written 6 to it. Let me write 3 just as a test. Haven't written it yet. Let's see what it's gonna say. Still saying 4. Let's write it down. It says 3 now. Perfect. That's exactly what I want. And then if I choose another register. Okay, I think it is working. No way. Oh, does reading require clock? Oh no, it doesn't actually. Very cool. So nice. Alright, chat. So I have 5 concurrent viewers right now, but sorry to disappoint each 5 of you, but I'm gonna have to leave right now. The stream has been running for over 5 hours, and I genuinely need to get some sleep. So yeah, currently I've almost completed this RAM module made of 8 registers, each of 4 bits. Tomorrow I'm gonna complete it for sure, and you guys have to subscribe. This series is genuinely gonna be amazing. But anyways,